that was discussed or part of finals. I hope everyone already accessed the pre-recorded lecture video on the reactions of alkynes and benzenes. Now, on that pre-recorded learning material, I have discussed on the latter part the reactions on benzenes. Diba? We have tackled the 5 most important electrophilic aromatic substitution under benzene. We have nitration. So yung tatandaan lang ninyo, for each type of aromatic substitution under benzene is the type of reagent that you have to be added in the reaction. Okay, so for nitration, you will just need a nitric acid in the presence of an acid catalyst, and the electrophile that will be produced or will be activated is the nitronium ion. So no problem kapag yung benzene molecule is unsubstituted. Diba? Pag unsubstituted, kahit saang part dito ng benzene, you can add, or not add, you can substitute the incoming electrophile. So saang part yan ng benzene, you can substitute the incoming electrophile. So no problem with unsubstituted benzene. So I have discussed to you the 5 most important electrophilic aromatic substitution. We have nitration, the electrophile that will be substituted to a benzene molecule is the nitronium. That is why the general product, major product is a nitrobenzene. So NO2 yung magsa-substitute, okay, displacing the hydrogen in the benzene molecule. Then we also have halogenation. It could be chlorination or via bromination. Chlorination, of course, chlorine gas is being added with the addition of a Lewis acid catalyst being stated there, or you can have bromine gas being substituted to a benzene molecule. Okay, so common sense lang kapag bromine gas yung sinubstitute sa benzene molecule, a bromo. Okay, a bromo electrophile will be substituted to any part of this benzene molecule, any of that carbon of the benzene molecule. That is why the major product is a bromo benzene. Kapag naman chlorine is being substituted, okay, being used as the reagent during halogenation of unsubstituted benzene, then the major product would be a chlorobenzene. Okay, then we also have alkylation, specifically a Friedel-Crafts alkylation type of reaction for aromatic substitution of benzene. So in this case, alkyl group naman is being substituted to a benzene molecule, wherein the source of alkyl, the source of your alkyl that will be substituted to any part of this benzene molecule is the alkyl chloride. Okay, so if you see an alkyl chloride, any alkyl chloride, you simply remove that chloro part, okay, chloride part of the alkyl, okay, alkyl chloride. Then kung saan yung point of attachment ng chloride sa alkyl chloride, dun din yung point of attachment niya towards substituting to the molecule of benzene. Okay, that is why the major product is an alkyl benzene. Kasi nga, what you substitute is an alkyl group. The source of the alkyl group is alkyl chloride. Okay, so these are just specific examples. I have discussed this already in the prior learning material posted. Then we also have acillation. So pag acillation naman, what is being substituted to a benzene ring is an acyl group. Okay, the source of the acyl group is the acyl chloride. Okay, you simply remove kapag i-substitute na yung acyl towards the benzene molecule, you simply remove that chloride part of the acyl chloride. Then kung saan yung unstabilized nga carbonyl carbon, yun din yung point of attachment niya towards the benzene molecule. Okay, so acylium ion yung electrophile. That is why the major product is, ayan, an acyl group attached to a benzene ring, or usually a ketone. Okay, yan yung major product natin. All right. So these are specific examples of acylation. Okay, I hope everyone already accessed the recorded video. Then lastly, sulfonation naman, the electrophile that is being activated using the following reagent, sulfur trioxide with acid catalyst is sulfonium ion. So sulfonium ion, iyahang simplified form is SO3H. It is the sulfur, ang point of attachment towards the benzene molecule. So in your case, since online class man, you don't need to memorize at all, no, the reagents. As long as you understand what electrophile will be substituted to a benzene ring, you know already, you can predict already the product. Very simple if unsubstituted yung benzene molecule. Walang substituent ba yung benzene? Okay, as in benzene alone lang. Kasi kahit saan ng part ng benzene molecule, pwede doon mo i-attach yung incoming electrophile. Okay. Now, for this session, for this afternoon session, we will still tackle these 5 important electrophilic aromatic substitution. All right. Only that this time we will discuss the reactions of those substituted benzene ring. Okay. Again, this time we will discuss how a substituted benzene undergoes those 5 electrophilic substitution reaction. All right? So whenever I say benzene, a substituted benzene, I am also referring to a benzene derivatives. Okay? Na kay benzene ring, okay? Then you can see a substituent, whether isa or dalawa or tatlo. Okay? So those are benzene derivatives or substituted benzene. So whenever ang benzene derivatives is already substituted, a benzene molecule is already substituted, those substituents, itong mga substituents na to attached, okay, originally attached to a benzene ring, will affect the incoming electrophile during the aromatic substitution reaction. So, hindi pwedeng kayo yung magdidikta, okay, di rin ako i-add ang katong electrophile or di rin ako i-add ang electrophile nga incoming. No. Okay, it is these substituents, okay, itong mga substituents na, na naka-attach sa benzene molecule, they will be the one to dictate the location of the incoming electrophile. Okay, so we will be learning the features, the related features that has to be considered in order for you to predict the major product for those benzene derivatives that do undergo electrophilic substitution reaction. Okay, so we have 2 related features that has to be considered. So may dalawang factors na kailangan nating i-consider in order to know or predict the ring substitution reactions of benzene derivatives. So first is the reactivity, the chemical reactivity of the compound compared to the benzene itself. We all know nga benzene alone, okay, yung benzene alone, that is already reactive. Diba? I have mentioned sa prior nga provided learning material I posted nga ang benzene is said to be electron rich. Diba? So kung electron rich, the best term nga atong i-describe sa iya, it is said to be a nucleophile in this case during chemical reaction. Again, a benzene ring, it is already reactive, knowing nga electron rich siya. So during polar reactions, it will act as a nucleophile. Okay, that is why, diba, electrophilic substitution ang reaction kasi siya yung nucleophile. Ang gi-substitute nimo is an electrophile. So, electrophile plus a nucleophile polar reaction. Okay? So, I repeat, benzene alone, it is said to be reactive already. Okay? But what if ang benzene molecule already contains a substituent? Okay? How can this particular substituent on a benzene ring influence the reactivity of the compound as a whole? Does it decrease the reactivity of benzene ring or does it increase the reactivity of benzene ring. Okay? So, mo na siya ato ang i-tackle karon for the relative reactivity factor. Okay? That has to be considered. Let's say, for example, in this benzene derivatives, as you can see, ba, kanang mga highlighted nga mga substituents, sa first structure, you have an OH attached to a benzene molecule. Structure 2, you have a methoxy at a OCH3 attached to a benzene molecule. Sa structure 3, you have an amine group, NH2. Okay? Now, ang inyuhang una-unaon karon, di ba, benzene alone, electron-rich na siya. That makes it reactive. Mas musamot siya reactive ang benzene molecule kung mas mu increase ang iyahang electron-rich characteristic. Nakuha ninyo? Electron-rich siya, reactive na siya. Musamot siya ka-reactive if naay mag-donate sa iyaha og much more electrons. Nakuha ninyo? Or ma-maintain man lang iyang reactivity. That sustains the nucleophilic character of benzene ring. Now, for these examples of substituents highlighted, OH, OCH3, and H2, these substituents are just few examples of substituents that could increase the rate of electrophilic substitution. Ilahang ginapa-increase kumbaga ang pagka nucleophilic ni benzene ring. Okay, how? I want you to observe the atom that is directly attached to a benzene ring. On the first structure, it is oxygen. Now, look at oxygen. It is further bonded to a hydrogen. We all know that oxygen, these are electronegative atom, tama? Electronegative atom yung oxygen. Meaning sa electronegativity property, recall, isa siyang atom, property ng atom that attract electrons toward itself. Okay? Kaya niya mag-pull og electron paingon sa iyang self. Now, oxygen and even nitrogen, di ba? Oxygen and nitrogen, even fluorine, di ba? Phon ang ato ang mnemonics ana for highly electronegative atom. Kani sila nga mga atom, they highly attract electrons towards itself. And look at the oxygen here, nitrogen here, they are further bonded to electron poor atom or poorly electronegative atom, di ba? Carbon, hydrogen, these are least electronegative atom compared to oxygen, nitrogen. Therefore, kung inyuhang i-analyze ang pull of electrons, is it going to the right or going to the left? Ang pull of electrons, is it going to the left or going to the right? Ang pull of electron. Oh, very good. Going to the left. Kay mo pull man siya og electron, mo attract siya og electron towards itself. Therefore, in this case, ang pull of electron is going to the left direction as shown by the dipole moment. 'Di ba? Kung provide ta og indicator nga ang na ay unequal distribution of electron is using this dipole moment direction kung asa ang arrowhead, meaning mo to ang most electronegative atong padulong didto ang mga electrons, kumbaga nga na ang pagsabot sa dipole moment. Kung asa ang arrowhead, okay, mao to ang much more electronegative. So in this case as a whole, kani nga substituent attached to a benzene ring will help stabilize the benzene ring. How? Via donating electrons towards benzene. So kung mag-donate sila ng electron towards benzene, that makes benzene much more electron rich. 'Di ba? That is why sa inyuhang notes, kani nga mga substituents are just examples of activating substituent. Kay ilang mas gipa much more reactive ang benzene. They are activating substituents. So that is based on electronegativity ha. Kasi again, kaning mga directly naka-attach sa benzene ring, highly electronegative sila. So ang pull of electron towards themselves. Sila further bonded sila sa mga poorly or least electronegative atom. Okay? So ang kuha gyud ang attract sa electron towards oxygen. Asa man ang oxygen? Nasa left side. Okay? Now, si oxygen, dili niya kaya i-attract ang electrons in this a large molecule of benzene. Oxygen is just one atom. A benzene ring is a large molecule. Okay? Dili lang na siya single atom. It is a large molecule. Therefore, walay choice si oxygen diri nga directly attached or nitrogen diri nga directly attached sa benzene. Pag pull niya og electrons, okay, paingon siyang self, no choice, iya do yun ang madonate towards the benzene molecule. And that makes benzene molecule much more stabilized, much more electron-rich, highly nucleophilic pa gyud siya. So, highly reactive siya in this case. So, naatay mga substituent nga gapa activate, reactive pa gyud sa benzene. So, these are just few examples. I hope you understand why these substituents are considered activating substituents. Okay? And another term, they are electron donating substituents. Okay, so as discussed earlier, electron donating ang ginagawa nila. Kaya nag-activate sila more sa benzene molecule. Okay, let's have the other sets of benzene derivatives. As you can see here, yung mga highlighted nga substituents, you have a nitro group, NO2, a nitrile, CN, C carbon triple bonded to nitrogen, and lastly, this is actually an ester, no? Ano siya? Yung point of attachment is carbon, then duha daw ka oxygen, that is actually a carbonyl, then OCH3. That is an ester part. Okay, so this substituents daw po attached to a benzene molecule. Sila naman, these are examples of substituents that are said to be electron withdrawing. Okay? Withdrawing. Meaning, since, diba, as you can see, the point of the atom that is directly attached to a benzene, they are somehow further bonded pagyud to a more electronegative atoms. Diba? Kung inyo i-compare, ang mga directly attached nga atoms sa benzene ring, you have a nitrogen, carbon, carbon. On their right side, they are further bonded to a most electronegative atom. Diba? You have oxygen, duha pa gyud ka buok. Nitrogen is much more electronegative than carbon. Kani, duha ka oxygen sa third mole structure. Duha ka oxygen directly attached to, further attached to a carbon. Okay? So in this case, tell me saan yung direction ng pull of electrons this time. Is it right or to the left? Yes, very good. This time, it's going to the right. Okay? So yung pull of electron, attraction ng electron is going to the right. Kung asa yung much more electronegative atom, padulong yun sa iya ang pull of electron. So this time, ma-disturb, no? Ma-disturb ang electron delocalization ng benzene ring. Okay? Okay? So, padulong man sa right direction ang pull of electrons this time. So, I repeat, this kind of substituents, okay, attached to a benzene ring, they will probably cause this time deactivation of benzene molecule. Kasi nga, I mentioned earlier, ang pagka-electron rich ni benzene ring, that makes it reactive. Therefore, kung ma-disturb na siya in any ways, okay, ma-disturb na siya in any ways, somehow ma-deactivate ang iyahang property, yung nucleophilic property. So again, these substituents are examples of deactivating substituents or let's say electron withdrawing, ayan, substituents. Okay? So, inyo lang yung i-remember, ang benzene is highly reactive if it maintains its stability. Okay? So if ever na ay activating substituents naka-attach sa iya ha, that sustained its nucleophilic character during reactions. Okay? So kani siya ang activation, ang deactivation of benzene ring towards electrophilic substituent that may be correlated also to the electron withdrawing or electron donating influences of the substituent as measured by the dipole moments. Okay? So that is the first factor that you have to consider. Kasi later on, natin classifications of substituents, if it is an activator or deactivator. Kapag activator na sila'y characteristic nga position nga ginadictate sa incoming electrophile. Okay? So next, another most important factor, okay, that becomes that could affect the ring substitution reaction of benzene derivatives, that concerns the site, okay, ang location, okay, of the electrophile substitution. Asa mo occur, okay, ang electrophile substitution. So that has something to do with the orientation of the incoming electrophile. Asa ang site of electrophilic substitution reaction. So recall, di ba, when we talk about benzene, naatay mga position. Okay, position prefixes. Okay? Pag sinabing ortho, adjacent. Kapag sinabing parallel, kayong opposite side niya. Kapag meta, one carbon apart. Okay, so please take note for the orientation of incoming electrophile, yung mga activators, yung mga classified nga substituents as activators, ang ilahang ginadictate nga position sa electrophile, incoming electrophile, is an ortho and a para-directing position. Okay, let's say for example, yung kanina nga example, you have hydroxy, di ba? Hydroxy is, sabi doon, activating substituent. So let's say activator siya. Then the reaction, let's say any kind of, yung 5, sa 5, any of those 5 most important aromatic substitution reaction. So naa kay electrophile being substituted. Yung gagawin ng OH as an activator, yung didiktahan niya yung electrophile nga okay, papunta ka sa ortho position. And yung isang product sa para position naman. Okay? So, you have one product, imo lang awaton, OH, then asa din ipadulong ang electrophile. So, sabi kanina, isa is para position, di ba? Para position, ortho. Ortho is magkatabi. Ortho position. And the other one, so plus, the other product is in, ayan, para position. Okay? So, ayan. So, nga na yung pasabot sa number 2. Siya, yung activators, classified as activators, they are said to be ortho and para-directing. Yung mga activators nga substituents, they are said to be meta-directing. So the same nga mga type of aromatic substitution. Nitration pa rin, halogenation pa rin, what else? Alkylation, acillation, and sulfonation. Ang dito lang kapag benzene derivatives na, you have to consider the substituent attached already to a benzene ring. Kasi siya yung magdidikta saan ang position ng incoming electrophile. Ortho ba and para or meta ba? Okay? So these are the classification of substituents based on their orientation and reactivity effect. So naatay classification and these are fixed ha. Kahit anong references of organic chemistry, when we talk about benzene derivative substitution reaction, mo gina siya ang classifications of substituents based on their reactivity, based on their orientation. So under ortho and para directing activators, okay, mo ni sila, they are further classified into their strengths of their activating contribution towards the benzene ring. So no problem with online classes kaya you don't need to memorize this time the classification nga okay inyong memorization nga okay strongly activating mo ni sila primary amine, secondary amine, tertiary amine, hydroxy, methoxy, etc. Okay? So be kuan gid mo i-appreciate na lang ninyo ang advantages also sa online class kay di na mo kailangan mag-memorize sa uban nga mga technicalities, especially kung mga chemistry classes or other higher chemistry. But please do not practice yourself nga mag-anad bitaw mo. Okay, so karon pa lang make this as a training ground kung mahimo dili mo mag-open notes so di naman ako na makuan di na makontrol inyong di na ako mo makontrol during exam or quizzes maka-open notes man gid ta. Okay, biskan ako kung ako student karon maka-open notes kay kanabitang sigurista biya ta mga student bi sakto ba to akong answer. Although kabalo na gid ka na sakto gusto pa gid nato i-correct or assure bitaw. So no problem, i-open lang gid na inyong notes, no problem with that. Okay, so we have strongly activating primary amine, so NH2. Ang pasabot ani kani siya, okay, ang naka-attached okay sa benzene molecule. Okay, so kung kani nga mga substituent, these are considered strongly activating. Then we have moderately activating. Okay, this is actually an amide. Kani siya. This is an amide group wherein the point of attachment is the nitrogen. Okay, so ana siya. NH, kung ato siyang ayan, pakita iyahang much more skeletal nga position of the atoms. More siya, amide na siya. Di ba, amide is carbonyl, double bond oxygen, then sa iyahang side there is a nitrogen. Okay, so that is just an amide, but the point of attachment, take note, the point of attachment is nitrogen towards benzene ring. Okay, what about this one? This is an ester lang, but the point of attachment is the oxygen. So, ana na siya. Okay, diba you have a carbonyl group, then my OR, so that's ester. Okay, then you have phenoxy. Okay, phenoxy, ano na siya. Point of attachment towards benzene ring, then an oxygen, then yun, ana. Alright. Okay. Yan. Then weakly activating naman, we have any alkyl. Okay? Any alkyl group, so our group attached to a benzene ring, or a vinyl group attached to a benzene molecule, excuse me, or a phenyl. A phenyl, yan. You have a benzene ring removed with one hydrogen. Yan yung phenyl. Okay, again, kapag ang benzene naging substituent siya, phenyl yung term sa kanya, phenyl. Alright, so these are the subclassifications of the ortho and para-directing activators. Okay, let me give you an example. Okay, para madali na lang i-understand later on yung mga sample problems. Let's say, for example, the benzene derivative na siya'y attachment nga NH2. And on the other side, you have a CH3. Okay, then you have an incoming electrophile during substitution reaction. Okay, question. You have two activators. NH2 is a strongly activating group, while methyl is a weakly activating substituent. Diba kapag R, again, kapag R group, this could be any alkyl group, pwede methyl, ethyl, or any branched alkyl group. That's R, okay? Now, ang pangutana karon, kinsa ang mas mag-dictate karon sa position ng incoming electrophile? Do you have any idea? Kinsa between amine and a methyl ang mas mag-dictate sa position orientation ng electrophile? It is the strongly or weakly. Yes, very good. It is the amine group, because amine group is a strongly activating substituent. Very good. Therefore, the product would be, awaton lang gihapon na nimo. Kopyahon nimo ang original NH2 and CH3. Tsaka na yung substitution ng electrophile. Asa padulong ang electrophile? Ortho position ni amine. Siya man ang mag-dictate. So, iyang ortho position, it's either this one or this part. Now, since naa naman ni substituent sa pikas nga ortho position, a better nga product is katong naay, katong blank, katong empty nga carbon. Okay, so dire ang ortho niya. Unsa ang i-add? Electrophile. Let's say nitration ang reaction. So ang electrophile nga ma-add is NO2. Kung chlorination ang reaction, ang ma-add nga not add ha, ang ma-substitute nga electrophile is Cl. Okay, and the other product, since ortho and para man, the other one is a para position. So kopyahon balik, okay? Diba? NH2, ayaw ninyo kalimti kay mao man gyud ang original, no? Original niya nga benzene derivative. Ang inyo lang ma-change din sa product asa ang position sa gi-substitute nga electrophile. Is it ortho, meta, para? Okay, so CH3. Then yung para position is this one. Diba? So unsay ma-add? Electrophile. So muna siyang pasabot sa classification ng strongly, moderately, weakly. Okay? Sige. Kung isa lang, kung methyl lang ang naka-attach sa benzene molecule, no problem. Ortho position ng methyl and the other one is para position ng methyl. Okay, next. These are specific example. No? Let's have number 1. First nga equation. The reaction, tell me what is this type of aromatic substitution reaction if you add chlorine gas in the presence of ferric chloride. It is very obvious. Very good. Halogenation, or the specific type is chlorination. Okay? So kung chlorination, halogenation, unsa ganito ang electrophile nga ma-add? Naglibog, magkuan gid ko no, masayop ko. It's substitute gid ha. It's not add, substitute. Kay kung add gani, kung mag-add ka, mag-break gid ta og pi bonds. We're substituting here. Natay gina-displace nga atom here. We're not adding. Okay? So ang ma-substitute is a Cl. So kopyaha lang na methyl group. Methyl, CH3. Methyl is an ortho and a para. So nakay ortho nga product and para nga product. So let's say iyahang product first is an ortho. Okay? So it's either here or here. Dili pwede duha ang imong ibutang nga ortho. Pili lang ka as long as ortho position siya. Okay? So let's say diri na ako ibutang ang ortho, Cl. Ana. Okay? Then yung para position niya, okay, CH3, then para position niya at bang, no, Cl. Okay? So you will know what electrophile must be substituted. Kay mo naman ang clue nimo during the reaction. Kapag nitric acid, nitronium ion ang ma-substitute. Okay? So let's have this example. So you have a methyl gihapon, methyl CH3. It is again an ortho and a para-directing. So naakay NO2 here, and the other one is the para position of the nitro. So ana lang. Or in some other cases, pwede ra pud imong i-write ang nitro as NO2. This is just to identify that it is the nitrogen that is directly attached to the carbon of that benzene molecule. So pwede ra, paras ra na siya. Alright? Next, you have an amine group. This is also an ortho and a para-directing. Okay? So, ang product, you have, this is NH2. Awata lang NH2. Then, what is being added? I know, substituted. Bromo. Okay? Bromination. So, bromo. Ortho position, Br. Or, pwede ra po din yung ortho position, ha, is this side. It's up to you. parehas ramang gihapon na, 'di ba? Kung mag-imo na siyang in-name, 1 2 ra gihapon na. 1 2 1 2. Ortho position. Okay? Then the other para product is this one. So NH2 ako sang okay. So NH2. Okay. Then para position BR. So ana lang. Then lastly, 'di ba, you have OH. OH is a strongly activating substituent. Look at your notes ha. OH is a strongly activating substituent, whereas a methyl, 'di ba? Methyl na siya, weakly activating. Therefore, ang magdidikta sa orientation ng incoming electrophile, which is the nitro, 'di ba? Nitronium ion will be the electrophile that will be substituted to the benzene, knowing that the reagent being added is the nitric acid. Okay? So you have here the products. Awatara, OH, then CH3, ortho position. Okay? And the other one, para position naman ng OH. So OH, CH3, diri din sa parallel part niya. Okay? So, ayaw mong kalibog ha, kung kinsa ang mag-dictate, iyaha nga ortho position, iyaha nga para position. Okay? Sige. Sige, next. Okay na siya. Mura na siya akong gidraw kanang nasa inyuhang notes. Next, let us have the second classification, the meta-directing deactivators. Diba? I have mentioned nga ang mga deactivators, classified as deactivators, they are meta-directing. Okay, meta-directing sila. So example, na sub-classified gihapon sila based on their strengths to deactivate the benzene molecule. So we have a strongly deactivating substituent. Okay, so yan. You have a nitro, a quaternary ammonium, the sulfonium, di ba? Muna siya ang, di ba, electrophile nga ma-add if sulfonation. So if ever naanay sulfonium ayon daan ang benzene derivative, this is considered a meta-directing, a strongly meta-directing deactivator. We also have a moderately deactivating. Okay? So that is an aldehyde. So kung imo na siyang i-draw, okay? Ano rin na siya? Double bond O, then hydrogen. Mo yung point of attachment, yung carbonyl carbon. This is a ketone, no? Ketone na siya. Okay, carbonyl, then an R group. Parehas na. This one is carboxylic acid. The point of attachment is the carbonyl carbon, then OH. Okay? Then this is an ester. Okay? Double bond O, then OR. Then that is an amide. Okay, so as you can see, ang mga functional groups that are carbonyl containing, wherein ang point of attachment nila is yung carbonyl carbon towards the benzene molecule, they are considered deactivators, particularly moderately deactivating. Okay, so this is an amide. Yung kanina nga amide, di ba natin na-encounter kanina nga activator nga amide, ang point of attachment doon, di ba, is nitrogen. That is why activator yun. Okay? Sige. So please take note of this subclassification. Sige, let's have a sample general reaction ha, para atong ma-apply. Again, we're talking about deactivators. Deactivators. So akong question muna, between a strongly deactivating and a moderately deactivating, sino dito ang medyo may activating property? Medyo may activating property. Strongly or moderately? Very good. Moderately. Therefore, common sense dayon, during chemical reaction, ang magdidikta sa orientation, sa location ng incoming nucleophile is the moderately. deactivating. Kay moderate raman iyang deactivating power. So naa pa siya somehow activating nga gina-contribute sa benzene molecule. Kay kani strongly deactivating namang gyud iyahang gina-contribute. So dili gyud siya ang mag-dictate sa location ng incoming nucleophile. I hope you got it, no? So say for example, you have a benzene derivative, ang naka-attach is, let's say, a nitrile. So kani siya. And the other one, diri nga position, example na atay aldehyde. Okay, so aldehyde, ana lugar. Okay, so that is an aldehyde. So, kung naka-encounter ka, okay, nag-undergo siya og electrophilic substitution, kinsa karon ang mag-dictate sa position ng electrophile, incoming nucleophile? Is it the nitrile or the aldehyde? Tell me, is it the nitrile or the aldehyde? Very good. It is the aldehyde because aldehyde is just moderately deactivating. Okay, so siya ang masunod. Okay? So naakay meta-directing pa rin. Pero ang gi-follow na position ni electrophile is C, moderately deactivating. Take note, meta position. Okay? Asa ang meta position, ato sang i-draw ha, CN, then nadiri ang aldehyde group. Asa ang meta position? Ako sang i-highlight ang meta position, di ba? 1 carbon apart. Okay? So 1 carbon, it's either here or this one. So again, ang best position is katong part nga or carbon nga walay, katong empty, walay attachment. So diri nato i-substitute ang electrophile. Meta position ng aldehyde. Kaya siya man ang nagdikta. Okay? Sige. Specific sample problems ta. Okay, for the first problem, you have a nitro group. So no problem kay isa ra man ang substituent diridaan. Identify lang nimo kung meta-directing ba na siya, ortho or para. So nitro is a meta-directing, a strongly meta-directing substituent. Okay? So ano lang, draw nimo nitro. Then what is this reaction? Chlorination. Okay? So, it's either asa yung meta position, kani siya or diri. Isa lang ha. Pili lang mo. Either ana nga side as long as meta position. So, let's say ako man ang sulat, diri na ko i-substitute ang Cl. Do not ask me nga nung Cl ha. Based on the reaction na siya. Okay, chlorination man ang iyang gi-undergo. So, ang electrophile that will be substituted is the chloronium, the chloro. So, meta position. Ma'am, pwede ka tong dirimi? Yes, pwede ra po mo magbutang og or. As long as dili nimo iusa og add diri. Okay, dili na wrong na siya. Okay, pwede ra ka mag-or kung gusto gid kag daghan kag answer. Okay, so nitro, then diri, chloro. Okay. Then, second sample problem, you have an aldehyde and a nitro. So between the two, tell me asa ang mag-dictate sa location ng electrophile. Is it the aldehyde or the nitro? Very good.
Aldehyde, ma'am.
Very good. It is the aldehyde. Okay, kasi aldehyde again is a moderately deactivating. We're talking about deactivating man. Deactivating. So, katong mga gamay lang yung deactivating power. Okay? So, meta position pa rin. Okay? So, aldehyde is COH, then NO2. Kopyaha gid ninyo ha. Ayaw ninyo kalimti kopyaha ang mga naka-add nga original nga substituent. Tsaka, i-substitute ang incoming electrophile. So, meta position of this aldehyde, it's either here or here. 1 carbon apart, mo na siya ang meta position. So, it's up to you. So, let's say, diri na ko siya i-add ang Cl. HCl ha, kasi chlorination man ang reaction. So the other, pwede ra pod or deridion. Okay? Okay. Di na to isulat. Okay? Kay malangay ta. Sige, next. Last, no? Sample problem. You have a nitration reaction. Nitration reaction, ang masubstitute is NO2. So, identify na to ang mga substituent. If it is an activator or deactivator, then is it strongly or weakly or moderately activating or deactivating? OH, tell me. Activator, deactivator. OH. Very good. Sorry. OH is an activator. So, automatic na dayon. Activator, it's either ortho or para directing. What about nitro? Deactivator or activator? Deactivator or activator? Very good. Deactivator. In short, di na ka mag-compare kung unsa ang strongly or moderately this time. Kay generally, magkaiba gyud siya, activator o deactivator. So, dito ta sa activator, obviously. No? Piliun yun na to ang activator. So, siya ang magdedikta, si OH yung magdedikta sa location ng incoming nucleophile, which is the nitronium. Okay, so both ortho, na kay product nga ortho position, na pod kay product nga para position. Okay, let me draw. So, OH, NO2, meta position, ortho position, sorry. So, pwede dito. Muna siya yung ortho position. Then, the other product is para position ng OH. Okay? So, nitro. Alright? So, that is for the deactivator strongly, moderately. With, kung naapagod siya, activator. So, that is how to apply the classifications ng substituents. So, parehas na siya akong gidraw. Next, last na ni siya. Last, we also have a deactivator but ortho and para directing. Ma'am, ano man ni? Di ba kung mayroong tag-activator, ma'am, kay activator, sila ratong ortho and para. Kung mayroong tag-deactivator, meta directing sila. Okay, try to look at the specific classification nga na-belong sa ortho and para directing deactivator. Ang mga weakly deactivators, they dictate an ortho and a para position. I-analyze ninyo. Weakly deactivating. Nalang sila'y gamay nga property to activate. So, ang ilahang large nga characteristic pa rin, somehow, na sila'y somehow. I'm not saying nga naagyod, no? So, somehow, na sila'y somehow activating property. Kaya sabi dito, weakly raman. Very weak ra iyahang ability nila to deactivate benzene ring. So, ang ilahang position nga ginadictate, ortho and para. Okay, ortho and para. Kay dako gihapon ang chance nga naa sila'y somehow activating property kapag activator, ortho and para directing. So, what are this? Dali ra ma-memorize, mga halogens. Kung nakakita ka og benzene molecule nga naadaan fluoro, chloro, bromo, iodine, kani sila mga weakly deactivators, ortho and para directing sila. So please take note ha. So say for example, you have a chlorobenzene. Gi-undergo og nitration, di ba? This is nitration kapag ingani nga reagent, nitric acid with sulfuric acid. So unsa ang ma-substitute nga electrophile? NO2. Alright? So, asa padulong ang NO2? Sabi dito, ang chloro, ortho, and para directing. So, you have an ortho position and a para position. So, kana siya. Muna siya ang para position. Then, you have an ortho position. Ma'am, pwede dire sa pikas ang ortho position? Yes. Okay? It's up to you. Okay, ortho position man gihapon na. 1, 2, kung imo na siyang i-name, this is still 1 chloro, 2 nitro, benzene. Okay? Or, ortho, chloro, nitro, benzene. Alright? Sige, next. What about this one? OH and you have a bromo. Okay? So obviously, ang OH is an activator. Take note, OH is an activator. Bromo, what about bromo? Bromo is a deactivator. So ayun nag-compare kung weakly, strongly. Dito gyud ang mag-dictate gyud ang activator automatic. Okay? Automatic ang activator mag-dictate. So ortho gihapon, no? Ortho position ng OH, then para position of OH. Ito, ortho position. Bakit BR, ma'am? Bromination. Ang reaction is bromination or halogenation. Right? Sige. And the other one is para position, para position of OH. Ito yun. Ortho position, para position of OH. Right? Sige, let's have the following example. Okay? Okay, let me answer number 1. Then the rest, siguro mga 5 items. The rest of the 5 items, let's have number 4 and number 5, 6, 7, 8. I will provide this as a group work. Okay, group work siya, meaning written siya. Kailangan man gud ninyo i-draw ang product, no? So, group work siya. So, isa lang ka output per group. So, naman mo'y grouping, di ba? Na mo'y grouping sa block B and C, dili man mo under sa ako sa lab. Kung unsa inyong grupo sa laboratory ninyo, mao na siya ang i-group ninyo for this activity. Alright? Sige. So, number 1, a benzene derivative na kay, COOH, this is carboxylic acid. So, tanawa inyong notes, asa na bilong ang carboxylic acid. Then, you have a chloro. Okay? So, tell me, kinsa ang mag-dictate sa electrophile nga nitro? Nganong nitro, ma'am? This is nitration reaction. Di ba? Nag-add og nitric acid. Okay? Tell me, kinsa ang mag-dictate. Is it chloro or carboxylic acid? Okay, very good. No, very good. It's the Cl. Okay, it is the Cl. Kasi Cl is weakly deactivating. Whereas carboxylic acid, deactivating din siya, but moderately. Okay, moderately deactivating. So kapag deactivating ang inyong gina-encounter, dito ka sa pinaka-weak yung deactivating property, siya ang magdedictate sa location ng incoming electrophile. So in this case, let me draw the product. Dili na lang ako ibutang ang product, ha. Supposedly sa right side yun. After this arrow, dira din ang product. So dili na lang na ako siya ibutang kaya wala na may space. Okay, so you have Cl. Then this one is COOH. Para position of the Cl. Okay, this one. So na dere nitro. And the other product plus. Okay, you have a benzene molecule. Cl, COOH. Para position of the Cl. So dere. Okay, and nitro. So these are the para and the ortho position ng chloro. Okay? As the substituent of the benzene derivative. Next, okay, no problem, isa raman ang substituent. So inyo lang kung anon kung ortho, meta, para directing ba siya. Okay, what is this reaction? Tell me first, what is this type of reaction? Is it acillation or alkylation? Very good. It's acillation. Dali ra ninyo ma-identify kung acyl ba kaysa kay alkylation. Kasi ang acyl, na kay makita nga carbonyl. Carbonyl, di ba? Carbonyl is carbon double bond O. Then na kay Cl. Okay? So mo siyang acyl nga part. Tangtanga lang ng chlorine dira. Mo na siya ang point of attachment towards the benzene ring. Alright? Sige. So, ethanol ang giadd diri. gi-substitute pala sa benzene derivative. So bromo, again, bromo is an ortho and para directing. So you have an ortho, asa man na ako ibutang, diri na lang sa baba. Okay, so na diri bromo, iyang ortho position, let's say mo na siya. Okay, so carbon, then CH3. Okay? So, pwede nga na. Again ha, ang point of attachment niya towards the benzene molecule is yung carbonyl carbon. Carbonyl carbon, ito. That is the carbonyl carbon. So, be careful upon drawing the or attaching the incoming alkyl or acyl group. Then, the other one, plus, the other product is yung para position ng bromo. So, nadiri ang bromo, this time, para niya, dire. No, para position. So, CO, then CH3. Mura ni siya ang gi-add. Okay, kana nga part, CO, then CH3. Okay, next. We have here a benzene derivative wherein ang naka-attach na substituents are a methyl and a chloro. Methyl is an activator. Okay? Chloro is a deactivator. Okay? Whatever their strength is, dito paghihapon ka sa general classification nila. Na belong man si methyl sa activator, si chloro deactivator. Okay? So, dirita kay methyl. Si methyl ang magdidikta. Okay? For the position of the incoming nucleophile. The incoming nucleophile is nitro because the reaction is nitration. Alright? So, you also again have a para and an ortho product. Okay? So, let me draw. So, you have here the CH3, then Cl. Ortho position first of CH3. So, kani. So, you have nitro here. Then, the other product plus, kamo na mag-arrange sa inyong notes, ha? The other product, you have CH3, Cl. Alright? Then, ayan, para. Para position ng CH3 here. So, nitro. Alright? So, the rest of the items, you can try this at your home. Then, i-fill in ninyo sa inyong answer sheet. Mag-post lang ko og material para dito ninyo i-turn in ang inyong activity. And by the way, I will be posting also the assignment 5, the scores that you will get from assignment 5. In Google Form ni siya. In Google Form, ang akong i-post karon. The scores will be recorded as lecture quiz. So make sure hakatutan na nga assignment